very good afternoon to one and all. So we'll just start this session. It is a 4th day session, afternoon session. And now I'll be just giving you an insight on harmonic elimination in an MPPT based PV fed multi-level inverter and its hardware interface. So mainly I have already told you about MPPT based PV. We have already seen the perturb and absorb, incremental conductance method and all these things. So now what we are going to see is this PV system, when you connect it to any inverter. Okay, so just think that this PV is connected to an inverter. So you have a DC, you had a DC to DC converter, which gave you the required DC, and that DC is connected to an inverter. So this inverter will now just convert this DC to AC. And now the AC is required AC we have got. You can either connect it to any standalone load or you can connect it to a grid anyway. Okay, so this is what is the main thing. But one main issue which will come is when you connect it to a grid or something, the harmonics should be between a particular limit. So what is the limitation? Any idea what should be the harmonic limit? Below 63 kV, okay, you have a limit of THD. How much is allowable according to IEEE standard? So according to the IEEE standard, the THD, allowed THD is, according to IEEE 519, the allowed THD is less than 5%. Less than or equal to 5% is allowed. Okay, this is the total THD, total harmonic distortion. But if you take the individual THD, that is the third harmonics, the harmonic content, you can say third or fifth or all these things, it should be less than 3%. So the individual component should be less than 3%, and the overall component should be less than the 5% according to the IEEE 519 standard. So now today's lecture, this is what we are going to see. How will we eliminate this THD, or how will we minimize this THD in order to bring it to the required limit? So why this THD is introduced in the system? Any idea why this THD is coming here? THD in the sense that the harmonics. Yeah, very good. Power electronic devices are used. So due to the switching of these power electronic devices, is it the only reason? Okay, noise is introduced because of interference. Huh? Okay. Inductors introduced in the circuit and all these things. Apart from that, this renewable energy, if you see, because we are talking about renewable and power electronics. Yeah, not only that, this PV is a non-linear, it has a non-linear characteristics. Okay, and it is non-uniform also. So when such a system is connected, what will happen? The DC is not uniform. So when it is converted into AC, automatically their harmonics is introduced. Apart from that, power electronic devices are there. So because of these power electronic devices also, THD is introduced. So our main aim is to eliminate these THD. Can you tell me some methods by which you can eliminate THD? Harmonics, if you want to eliminate the harmonics, how can we do this? Okay, one is by modulation technique, one is by filtration. So you can have some filters, LC filters or some hybrid filters, active, passive, all these filters you can use. And one sir has said that is modulation technique. So which one is best? Can you go for modulation technique or you can go for filtration? Yeah, some places both also they are using. Modulation technique is best. The reason is, say if you have some filters, again non-linearity, you have LC, again L and C parameters. So the complexity of the system is again increasing. Okay, the cost of the system is increasing. Again you have to control these things. Size of the inductor capacitor is increasing. And sometimes that is not required. Sometimes, like say it is of overrating. Sometimes it is not used. Sometimes extra usage. So yeah, availability, all these things are there. So better to avoid these filters and go for modulation techniques, because anyway these thyristors need to be fired. Okay, we have to anyway fire these thyristors. So now you fire those thyristors at the required angle, then automatically these THDs are eliminated. So that is what we are going to see today, how to use this methods, this elimination technique, or many techniques are there. You have selective harmonic elimination technique, you have SVPWM, you have carrier pulse PWM. But each method has its advantages as well as disadvantages. So if you go for carrier pulse, you generate the firing at very high frequency. You have to just produce the carriers also at very high frequency. So very high frequency, again, the device you required, so you have to go for FPGA. In that case, surely you can't go for microcontrollers or anything. And similarly, the switching frequency is increasing automatically. What will happen? Switching losses are increasing. So again, we have to, these modulation technique also, we have to just see which method to use. And the best method is fundamental switching schemes. Fundamental in the sense, say 50 hertz is the output we require, and the same frequency you just do the switching. That is the best technique you can have. Okay, so this is the thing. Now, you would have heard of different types of inverters. Say first we saw PV. Any PV is there, we will be using a charge controller, DC to DC conversion, to get the required level. That is there. Once DC ready DC is there with us, we just connect it to the grid using an inverter. Okay, because our concept of DC houses have not come. In India, it has not come. In many other countries, the DC houses they are using, where DC will be directly converted to DC using the DC charge controllers, and the house itself is a DC. But in India, anyway, you have to go for an inverter. So inverter also, many types of inverters are available. Okay, you have PWM inverters, you have series inverters, parallel inverters, sinusoidal inverter. What do you really mean by sinusoidal inverter is, there, say, whenever you're converting DC to AC, it is a, say, DC is a constant value. Okay, you're converting into AC, how will you get? You can just see the waveform here. Say, I'm just showing you. Let us. So this is the DC. Okay, DC output. Say you have a DC. See, this is your DC from a PV. From a PV source, you are getting this. Now, using an inverter, you have inverted it. So how will you get? First, this DC is there. Then after that, when it is switched in negative, you get the negative portion. So this is the AC now. So this AC surely will have lot of harmonics. Okay. Now, this is one type. But what a sine wave is, because whenever you have a AC load, you have to connect it to connect this inverter to a AC load. You should require pure sine wave. Otherwise, your load also will get damaged. So here you require a pure AC. Getting a pure AC is little difficult. You can have anyway inductor capacitor circuit like series and parallel inverters. You would have series inverter. You would have seen you get little pure sine wave, but still it is not pure sine wave. You get sine waves like this. You just don't get pure sine waves. So like you get sine waves like this. Okay, so this is also not pure sine waves. So one method is going for multi-level inverters. So already two classes, like little introduction, you would have got multi-level inverters. Why we are talking about more multi-level inverters? When it is a renewable source of energy, when you want to connect a renewable source of energy, these multi-level inverters are best. Okay, so can you tell me what are the different topologies, basic topologies of multi-level inverters? They are the levels. There are, say, cascaded H-bridge multi-level inverter that you would have seen. Mostly cascaded H-bridge is good for renewable energy sources. So that's why we all would have discussed that. Apart from that, you have diode clamped and you have capacitor clamped. Two types, diode clamp, capacitor clamped, and then flying capacitor. The capacitor clamp is otherwise said to be flying capacitor type. And you have this cascaded multi-level inverters. These are the different types. Still, all would have talked about cascaded. What is the reason for cascaded? We will be just seeing here. So in this case, any type of multi-level inverter, what actually is done is, depending on the solar, you have different solar panels. Say first one solar panel, you get output like this. Now cascade 2 solar panel, you get a step like this. Cascade 3, you get a step like this. Cascade 4. So now you can get stepped output, which is almost similar to that of your AC. Okay, this is how this is. So now whenever you talk sine wave inverters in the market, it is the stepped inverters like this. Multi-level inverter. If it is multi-level, it is the stepped inverters like this. So this one, if you see, it is somewhat equivalent to your sine wave. Still, it has harmonics. Okay, it is not pure. It is still, it will have harmonics. Now our main aim is to eliminate this harmonics using modulation techniques. Okay, filter. Why we are not going for filter? We have already discussed. We will not go for filtering. We will go for these modulation techniques. So this is a chart which will give you an idea about the number of switches and number of capacitors and diodes. Okay, so here you can see. Let me just enlarge and show you. So you can see 2 level, the number of switches 12, no diodes and capacitors are required when it is cascaded. Then 5 level, diode clamped, you can see 24 switches, then capacitors 12 and diodes are 36 diodes. Okay, and it is, if you see a diode clamp, it is medium weight because number of components, if you see it is 12 and 36, costly, low power loss, and the THD is greater than 15%. When you go for 5 level, the THD is greater than 15%. Similarly, the capacitor clamp, you can see it has 30 capacitors. It doesn't have diode, but 24 switches are required. But when you go for a 5 level cascaded inverter, only the switches, 24 switches are required, doesn't require any capacitors and diode. So automatically you understood why we go for this cascaded H bridge. Okay, another thing is in cascaded H bridge. So now I'll just show you the 11 level, because in 11 level you get THD less than 5%. Okay, for less than 5%. So I already told you, according to IEEE 519 standard, your THD, the THD should be less than 5%. And what about the individual harmonics? It should be less than 3%. Okay, so individual harmonic content should be, that is a third, fifth, seventh, 11th, 13. All these harmonics should be less than 3%. It is IEEE 519 standard, STD. Okay, IEEE 519 standard. It is, I think, 19. You have a year also, because 2006 also again it was revised, but this is 1996. I hope you can just check it in internet. I am, according to my knowledge, it is 1996. Okay, so the IEEE 519 standard 1996. These the standards are like this. It should be, the total THD should be less than 5%, and the individual harmonic should be less than 3%. So you can see here, so that's why we go till 11 level. Mostly when you reach 11 level, automatically your THD will come less than 5%. 5%, I'll show you. And here we have come to a conclusion that cascaded 11 level is the best method. Okay, cascaded 11 level is good. But like the main disadvantage of this cascaded 11 level, if you see, it requires isolated DC as well as constant DC. Then only it will give you good output, like THD also will be minimized. It required an isolated and constant. So that makes the advantage in case of these renewable energy source. Because renewable energy source, if you see, that is an isolated supply. Huh? Yeah, battery. That is the renewable energy also you can store in the battery and you can take, but they are isolated. Okay, they are isolated. The other thing is you can make it constant using, as I said, battery. You charge a battery and from battery you take it. Then they are isolated. So here each and every DC what you are using should be isolated. It is not like that, say you're converting AC to DC and rectifying it and taking a multiple DC like that. You should not take it. Here every DC should be, say in case of 11 level, for single phase you require 5 DC sources. For 3-phase, 15 sources. All these 15 sources should be separate source. So you all know, whenever you're erecting PV panels, it will not come as a single big panel. Why? If small portion is shaded, the whole system is disturbed there. So mostly these panels you would have seen, they keep different modules only. So you have more number of DC sources. The best method is this cascaded multi-level inverter. Okay, so you have single phase 5 DC sources required. You go for 5 panels, 15 panels, very best. The topology is a good thing. So there are number of research going on to reduce the number of switches. But when they reduce the number of switches, that is very good. So now people work on this cascaded multi-level inverter trying to reduce the number of switches. But again, reducing the number of sources also is going on. But there is no need. What we feel is, instead of reducing the DC source, because whenever you go for a PV system like this, where maybe wind, you want to connect a wind, then reducing the number of sources is good. But PV, mostly what we suggest is, you have number of sources, because PVs comes as different modules and partial shading and all these effects can be overcome. So for PV, this topology is the best. Yeah, yeah. Uh, Individual PV panels can be used, but say if the rating is less, then you can go for array, and array can also be connected here. But it is a isolated source there, because all these PVs though connected in this thing, final output is an isolated. Okay, it should not be interconnected. That is what is meant. Yeah, number of arrays can be gathered together according to the rating. So it depends on the rating. Your panel is a small rating, then you require a DC input which is higher, then you can go for arrays and you can connect it. Okay. So this is the advantage of this 11 level cascaded multi-level inverter. Okay. So here you can see the cascaded H-bridge multi-level inverter. So already you would have all seen this thing. Sir would have already explained about this cascaded topology, and this is the DC. So in this DC portion, what you can do, you can have your solar panel connected. So I just already showed you a MPPT based solar panel. So that panel we will be connecting here. So last class, I think all of you would have attended that. So where we connected. So in this place, even in the place of a solar panel, you can have a wind. Wind turbine can also be connected here. Okay, so you can have any DC source connected to this system. And one more thing you can see here, I have just shown you, this DC is not a constant DC. See here, VDC1, VDC2, say you have some 5 panels here connected to a single phase. This is only single phase I'm showing. So VDC1 is a different value. You have VDC2, which is higher, but they're cascaded. And then we have VDC3, and this VDC5 is giving only a small voltage. Okay, they are different voltage. So this is what I said. When different voltages are coming, THD will still increase. If they are equal, somewhat less voltage is there, less THD, like THD will be little more less. But if that is unequal, again the THD will increase. So that also, there also we have a scope to reduce the thing. And you know, PV panel is not surely going to give you constant voltage. They will be varying. They will be varying. Even if you try to track a constant voltage, also still there will be some small changes. Okay, so you can. And why we are not going for battery? Because battery maintenance is very difficult, and bulky and costly, and maintenance. All these things, if you see nowadays, mostly it is online PV, like grid connected, direct grid connected PV. They are trying to avoid battery, but still, when you avoid battery, there are more disadvantages. During night, you cannot use it, and daytime also suddenly there is a shutdown or something, again synchronizing, many problems are there still, but people are again doing research into it, how to make it online. Okay, so this is a thing which till now we saw, and now this you can see the system which is here. Can you identify the system which we already discussed? The PV panel with the sensors, voltage and current sensors, the DC to DC converter buck, and this input is given to the cascaded multi-level inverter. Okay, so here this is only one PV source that is given. Similarly, you will have, say if it is a 11 level inverter, 5 such things. If it is a 3-phase 11 level inverter, 15 such modules are required. Okay, and now our main aim is when these are connected, and in this case what we did is, in our laboratory when we did, we made this voltage, output voltage, constant at the output end. Without battery also we tried to make it constant, but still it cannot be made very constant. We were trying to take around 12 volts as output. So we had a constant voltage tracker. Again, the output end also, this we had a like here we had a sensor. That value also we took inside. We compared with a reference. If the value was above that reference, that is above 12 volts, we just decrease the duty cycle and we tried to track it to 12 volts. And the other thing is, at the same time, we was just monitoring the input PV, our input. And in that case, when the irradiation was going low, the PV voltage was also going low. So in that case, we had to use MPPT, and we were trying to increase the voltage. So we just had a different algorithm there, and we were trying to track a constant voltage output. So still, I told you that perfect 12 volts was not possible. Maybe 11, when we did this, 11 volts we got, sometimes around 12.5 volts we got. So how, when this difference is there, how to eliminate the THD, that also we will be seeing. Okay, so this is a thing. So here you can see the equations. Okay, I'm not going to frighten you with these equations. I'll tell you simply, don't worry. Okay, yeah, nothing is complicated. Once I finish, you will tell, oh, this is nothing. So the output, what we get here is in this form. So all of you would have, like say, I'm not taking the step also, simple, I'll just say, this is said to be odd symmetry. Okay, odd symmetry. You have even symmetry waveforms, odd symmetry waveforms. You would have. This is odd symmetry. So when it is odd symmetry, all of you know Fourier transform. Frequency analysis we are going to do. So we know, you know, Fourier transform. In Fourier transform, with this voltage, when you write this voltage, you write it as V is equal to A naught plus an into some function, yeah, cos something, plus bn into some sine something. So since it is odd symmetry, a naught, that is a DC component, we eliminate. An, that is that component also we eliminate. Only the bn terms come. Okay, bn into some sine term. So that is a term given here. So this voltage is nothing but, this is an odd symmetry. We have this function plus sine omega t. Okay, so this term is that term. Yeah, Bn is 4 by n pi into the different voltages in this case. Yeah, integral of these things. Same thing. You have to use it here. Yeah, this is from papers. And you can even refer Rashid book. Rashid, they have a chapter of multi-level inverters where THD minimization using this selective harmonics they have done. So there also you get it. And usually Talbot, you can refer all Talbot's paper. There also they have discussed all these equations. Okay, for all the multi-level, not only cascade, he has discussed with diode clamped and even capacitor clamped. Okay, so many papers are there. You can just refer it. And here we require something called the modulation index. Say how we did this 4 by n pi, we brought it to the left hand side. This 4 by n pi, just bring it to the denominator here. Okay, so this is the fundamental you just take. This VDC here, if you see, this VDC1 is a different, VDC2, these are the different DC voltages. That also I am just taking summation of all those things down here. So this V1, that is the fundamental voltage divided by these term, we are just telling that is my modulation index. Okay, so modulation index. Yeah, it is the definition. Modulation index is fundamental divided by 4 pi, so summation of all the DC voltages. Okay. So now this modulation index depends on the DC voltage. When the DC voltage changes, the modulation index will also change. Okay, fundamental is what we require, 50 hertz. That we know, this is the fundamental. But the varying thing is here the DC voltage. Depending on our DC voltage, our modulation index is also changing. Just remember that now. So now what is our main aim? This method is nothing but selective harmonic elimination. We want to selectively eliminate some harmonics. Which is the deadliest harmonic? Which is the deadliest harmonic? Third harmonics. Automatically क्या हो जाता है? Yeah, in case of a single phase supply, when the supply is single phase, this third harmonics will be there. But when you go for a 3-phase, automatically the third harmonics will be eliminated, and even all the even harmonics will also be. No, not all the multiples of third will not be eliminated. You will have 9 and all those things are there. Third harmonics will be eliminated. Even harmonics are also not there. Only so which is it in case of a 3-phase system, which is the deadliest harmonic? Fifth is the deadliest harmonics. Okay, when third harmonics is not there, the second thing. Why we say that is deadliest? Why we say that? Say when you take a AC supply, okay, so we have a AC supply here. Okay, third harmonics kaise hota hai? Third harmonics is it has 3 cycles. In one cycle itself, it will make 3 cycles, something like this. My diagram is not so good, but anyway, I can adjust it. There are 1, 2, 3. Okay, so here if you see in this case, the resultant, आपकी जो fundamental third, when there is a third harmonics, your resultant output voltage will be something like this. Like there is a dip, you just add it. So automatically here it is okay, but this after this portion, what it happens, there is a dip. Okay, so because here there is a thing, so there it dips. This portion, this negative portion will try to get cancelled with the fundamental, and there will be a dip. And what about the fifth harmonics? Fifth harmonics, if you take this fifth harmonic, it has 5 cycles here, almost 5 cycles. So 1, 2, 3, 4. Like again, I went little wrong. So here, so you can, one thing what you can remember is the fifth harmonics magnitude will be less than the third harmonics. As the harmonic order increases, the magnitude will go down. So we are not worried about higher or harder harmonics. They will not change much our voltage. So the lower order harmonics is dangerous. For a single phase system, third harmonics is the deadliest. For a three phase system, the fifth harmonics is the deadliest. So here we are considering a three phase system. Okay, so what we require the fundamental voltage. So that is what we have written. This voltage is required. This is the fundamental voltage that is equal to Mi. We require it. What are the things we don't require? VDC1 costs 5, 5th harmonics, 7th harmonics, 11th harmonics, 13th harmonics. I am just equating it to 0 because this is selective method. I am telling these harmonics, let me eliminate. Why I took only these 5 equations? Why didn't I take the 15th harmonic? 15th also? No, it is not like that. That effect is also there. But why I took is, now here, see how many unknowns are there. The VDC1, VDC2 also say what is the DC voltage coming, we know that. Modulation index also fundamental by this, that is also known. The unknown are alpha 1, alpha 2, alpha 3, alpha 4 and alpha 5 are the unknown values which we have to find. There are 5 unknowns. So if there are 5 equations, you can solve 5 unknown. You need not go for more number of, you will not, if you take more equations also, there is no use of, it will not get eliminated. Okay, there are 5 unknowns, so 5 harmonics you can eliminate. You choose which are the harmonics you want. That is selective harmonic method. You choose it, which you want. So I will surely choose only 5, 7, 11 and 13 because I don't go for 15 because 15 se deadliest, 13 hai. Okay, is it clear? So I have just taken these equations. And these equations are said to be the transcendental equation. Now you have to solve this and get alpha 1, alpha 2, alpha 3, alpha 4 and alpha 5. It is very difficult to solve this. It is not so easy to solve this in mathematics. Okay, those who are from mathematics background will know. So for this, you go for different techniques like say Newton-Raphson, Gauss-Seidel. You would have learned the numerical method, numerical analysis, where you would have learned different methods to solve these things. Okay, Newton-Raphson method, or even you can go for optimization method. I just want to find what is the optimal value of alpha 1, alpha 2, alpha 3 and alpha 4 so that my THD is minimum or 0. Okay, so for that what I have to do for G and PSO, I have to just find an objective function. What will be my objective function? These equation which I showed you plus the THD equation. Okay, my THD equation will be root of the magnitude of all these voltage divided by fundamental should be equal to 0. My THD should be equal to 0. That is my objective. Okay, so that objective function should be minimized or maximized. How will you find whether you want to go for a minimization or maximization? Say efficiency hai, humko maximize karna hai. This is THD, unwanted thing. You have to minimize. Okay, so you have to go for a minimization problem. Okay, you understood now? So Newton-Raphson also you can do it. So now I'll be just showing you some methods. Newton-Raphson, GA, PSO, we will see how to eliminate this THD. So not only for this problem, if it is some other problem also, you can apply it in the same way. Okay. So here, one of the thing is, we can consider in this equation, we can consider, let this VDC1, VDC2, one second, the PPT, VDC1, VDC2, VDC3 and VD4, VD5 equal to Z, equal, they are equal karke kar sakte hain. When is the case? When you are connecting a battery. And if you are sure that the PV is being charged using a battery and battery is going to discharge, battery voltage is almost constant, then you can directly go for these things equal. You can say that. Okay. Or you are using some constant voltage tracker algorithm and you are tracking constant voltage, then also you can say this. But many cases when they are not equal, what you have to do is say this is the two cases. First case, I have made equal and I have put I have removed all the VDC1, VDC2. Okay. In the second case, if you see, I have just kept VDC1, VDC2, VDC3, VDC4 and VDC5 and I can solve it. So two techniques you can use here. So there are research scopes here also. So in the second case, what you can do, in the second case, what you can say is this, we can just assume that let my VDC be equal to, I can keep a constant voltage. Let the VDC be equal to some 12 volts. Okay, I'm just keeping, let my VDC be equal to 12 volts. So now what I can do is, I can just solve this equation. If I keep this VDC1 also, how many 10 unknowns are there? It is very difficult to solve that. So in that case, what I can assume that I require 12 volts. If the voltage here is 12.2, or the voltage is some 10, or it may be some 11 point something. I can keep, this is 12, so I can have say 1.1. I can fix it. I can just first initialize it. Let my VDC1 is equal to VDC, I'm taking common, that is 12 outside. From this equation, I can take this 12 outside. Okay. And after this, I can have this, if it is 12 itself, 1. This case, it may be 1.2 or 1.1. In this case, it may be 0.9. I can fix it. Okay. You can. So first you just keep, let my VDC1 may be 1.1. That is, you can take case studies. Case 1, when I am considering VDC1 is 1.1, VDC2 is 0.9, VDC3 is this. So all those values are fixed now. So only 5 unknowns are there. Solve it and get the answer. Okay. Similarly, for this is for a particular modulation index. Similarly, you go on doing for different. Now VDC1 value, you keep it as 0.9. Then you keep it as 1. Then you keep it as 1 point. Solve this equation. Take all these equation and train any network, or you make a lookup table. Okay, now you have that when my DC voltage is around 12.2, VDC1 is 12.2, my VDC2 is some 9 points, 11 point something. So what should be my duty cycle? You have already made a table. So you can fire your thing. So you can make it online also. So this work you can do it. I don't think so many people have done it, but not to that extent. So there is research scope in this area also. Okay, connecting to a grid, you just, the uncertainty of PV, what you can do is, you can predict if this voltage comes, what should be my duty cycle. Like that, you have to take different cases and find out what is the alpha 1, alpha 2, all these values. Okay. So next is, we have found all these, like now these equations are there, how will we solve it? So one method is Newton-Raphson method. Okay, Newton-Raphson method, first initially what you have to do, you have to give an initial guess. Alpha 1, alpha 2, alpha 3, alpha 4 and alpha 5. Initially you have to give a guess value. Okay, so let us consider that my angle will be varying from 0 to 180 degrees, is it? That is the thing. And 0 and 180 is not possible, I've already told you. So you have a range. So if you want to convert into radians also you can convert. It is not necessary always it should be degree. So radians also 0 to 1 ho sakta hai. So you can have different. So you can give a 0.4, 0.3 side like that. You can just give some alpha value as initial value. Okay. One of the disadvantages of this Newton-Raphson method is, if the initial guess is not very close to your answer, so it will take a very long time and sometimes wrong answer also. So that is a disadvantage. That's why you go for optimization based technique. Okay. So then after that, what we have to do in Newton-Raphson method, this is the procedure. Okay, this is the algorithm according to Newton-Raphson method. After finding this, after initializing the initial values, you have to find some matrix, that is the non-linear system matrix. So this equation already you know. This is fundamental, 5th, 7th and all these magnitude of voltage. Okay, that is nothing but your Fj. Differentiating this Fj with D alpha is nothing but your Jacobian matrix. That also you need to find. Then the harmonic amplitude matrix. You know what is the amplitude matrix, is it? First case, it is equal to modulation index. Where is my cursor? Yeah. In this case, it is modulation index, Mi. Then the second case, 0, 0, 0, 0. So that is your T matrix. Okay. So here you can see the Jacobian matrix you found, your T matrix you have written. You have a constraint, your alpha 1, because when you take a step here, so after step we say your alpha 1 should be greater than 0 but less than this alpha 2. Your alpha 2 should be greater than alpha 1 but less than alpha 3. Alpha 3 should be greater than alpha 2, less than alpha 4. Okay, and alpha 5 should be greater than 0 but less than 180 or 90. Here in this case 90. Okay, so you know this condition. So these are not equal constraints, they are unequal constraints, like less than or equal to I say bol rahe na. So this is unequal. So every time the constraint also you have to define. So here the constraints are given. Alpha 1 should be greater than 0 and it should be less than alpha 2. So this is the constraint. After that, what we do, we just find what should be the change in angle. Say first aapne initial angle kar diya, say 30 degrees. Now what should be the change? It may be 32. So that 2 degrees you are finding using this formula. So del alpha is equal to this Jacobian matrix into alpha j into T minus f of j. Okay, alpha j is the initial firing angle what you have initialized, plus T you have know this is this matrix, and f also the initial matrix, system matrix. Okay, and after that the new switching angle alpha. Next angle kya hoga? That is nothing but alpha k plus 1. That is nothing but the old angle plus this change in angle. Okay, and that you just transpose it, because wo jo region mein hai, you have to every time do a transpose in order to get the original alpha of k plus 1. That is a new angle. You do a transpose, that is absolute cos inverse of absolute karte samay uska original alpha value आपको मिल जाएगा. So this is the algorithm for Newton-Raphson. Okay, so Newton-Raphson algorithm is same. Only thing is here the objective function is different. Okay, in this case this is the objective function. आपके केस में कुछ और equation आपको solve करने हैं तो that equation you will go and put it. Okay, the method is same for every algorithm. Then you go on solving until the error is minimum. Like आपका THD कब 0 हो रहा है और minimum हो रहा है तब तक this you will go on. Okay, so let me just show you the Newton-Raphson algorithm. For 11 level, the Newton-Raphson algorithm is written. Next, we will go into GA. ये finish करने के बाद. So this is the Newton-Raphson algorithm. You can see here. We are just defining the for loop, and 5 level is 5 DC sources hoga, so that's 5. And this is the initial guess what we have given. So ये radians में है, so 0.4, 0.41, 0.42. This is the initial. Any guess you can give which is close. So हमने तो different initial guess से solve करके देख लिया था. And after that, say here we will just define the matrix. This is the initial system matrix. Okay, after that, see all the, this is your T. In that algorithm I gave it as T, that is modulation index 0, 0, 0. This is the F value, the system matrix. This is your Jacobian matrix. So just write all those things. And after that, your THD is nothing but the like absolute. यहाँ THD का single portion है. यहाँ आपका ये individual harmonics है. 17th harmonic कैसे find करेंगे? 19th harmonics, 23rd harmonics. Okay, so individual harmonics, and this is your THD. So THD till the 13th. आपको 13th harmonics तक THD find out करना है, तो it is the square root of all the individual harmonics. 7th harmonic, आप जो भी eliminate कर रहे हैं, 5th harmonics, 7th harmonics, or 11th, 13th harmonic divided by fundamental will give you the THD. So OTHD, this is till 13th आपको find करना है, और higher order और भी higher जाके देखना है, आप उसका equations अब लिख सकते हैं, और उसको display करने के लिए plot commands दे दिया. Okay, so in this case when you just run the algorithm, you have to just write down the algorithm properly, and if you run you will get all the angles. Okay, and error. Now अभी क्या करेंगे? आपका this is modulation index. हमने modulation index मैंने इस केस में first of all 0.4 से 0.8 तक वेरी करके इसको find out किया है. So now what I do is for 0.4, these are the 5 angles I got. Okay, say 0.8 मुझे 0.7 मिल गया, तो 0.7 में these are my angles. So ये आपका जो workspace है, these angles will come to your workspace. आप workspace में जाके angles find out करना है, तो you can just go to your workspace and note down all the angles. आपको modulation index के साथ angles भी मिल जाएगा. Okay, this is in radians. Sorry, angle it is in degrees. Okay, so यहाँ जाके आपको angles and this मिल जाएगा, आपका modulation index and angle. So now what you have to do is you have to go to your problem, like multi-level inverter की एक program मैं open कर देती हूँ. So इस problem में क्या है कि I have just connected my PV, which I already showed you in the last class, to all the H bridges. So there will be 15 PV connected to this model. So you can see here the model. Okay, so this is the model. I am simply connecting here the DC source, sorry, DC load. induction, sorry, not DC load, I'm very sorry, induction motor. I'm connected because AC and output is AC. I'm just connecting an induction motor here. This is my multi-level inverter. So this is the multi-level inverter. You can see here the thing. So here, this is the H bridges. Okay, in MATLAB you have the option for universal bridge, which will have all the four. It's a H bridge model, or you can have four switches as such. But here it is a H bridge as such. So आप universal bridge को यहाँ जाके अपने power electronics में sim power system में चले गए, वहाँ से वो component डाल सकते हैं. And here these are the PV sources connected. Okay, so here I told you in single phase there are 5 PVs connected, and in 3 phase 3 such PVs are connected. Okay, so 15 PV panels I have connected, and this PV is the same thing which I have already showed you. Okay, so हमारा जो PV, buck converter and all these things, all the algo, same PV which I already showed you, same thing. I am connecting it here. Okay, so now from where did I get these angles? So yeah, for this all the angles are coming here. So जो angles हमने find किया ना in using Newton-Raphson, alpha 1, alpha 2, alpha 3, alpha 4, alpha 5. So those are the angles here. Then what we do for this, it will go directly 180 degrees phase shift. It will go to this. Sorry, 120 degrees. 120 degrees because each phase is shifted by 120 degrees. So 120 degrees phase shift, it will go to this phase. Again 120 phase shift, it will go to this phase. Okay, is it clear? So that is how you do the firing. So from where this firing angle is coming, I am using a phase lock loop. Okay, I'm just measuring the voltage here and I'm just taking as input. I'm having a phase lock loop, and that I'm just comparing, and I'm modulation index. I'm just measuring what is the modulation index. According to the fundamental voltage, according to the DC voltage, I'm just measuring what is my modulation index, and I am giving the angle here. So whichever angle in radians I got there in Newton-Raphson for a particular modulation index, I am giving here. So here in this case, I'm doing it for a particular DC value. So modulation index is fixed. Say 0.7 modulation index. I know the angle. I'm just giving it here and I'm firing. So you can see here this is the gain block डाल के मैंने वहाँ radian पे angle दे दिया. Just double click on this. Just double click on this A1. This is the go-to block. You just click on the link. Automatically it is coming here. From that where it is coming here. Okay, is it clear? Here also you can just click and see. I just click on this link, it will come here. So what we have to do, say this is for Newton-Raphson, I have given the angle. When I find for GA, come here and give it for GA. GA angle you give. Okay, GA will also give you some angles, 5 angles. You come and give the GA angle here. When you find it with PSO, come and give the PSO angle here. Okay, when you want to do it online, in this case only one, I am measuring the modulation index. For when that particular modulation index comes, I am giving the gain here. This value is fixed. You can remove this. What you can do is you can put a neural network in this position. In this place, you can put a, here what you can do is you just remove this and put here a neural network. Okay, so based on the neural modulation index coming, neural network will give me the optimized output. Like it will give me the intelligent. It will just see. So you took the GA value. Okay, आपने GA के firing angle you have taken for different modulation index. You have trained the neural network. Now the neural network, when particular modulation index will come, उसके corresponding theta alpha 1 alpha 2 value, the neural network will give you as output. Or you can even use a lookup table. Okay, lookup table, what it will do for a particular modulation index, it will give you what is the angles, corresponding angles. Okay, so it is very simple. Okay, so now let us run this and see. This is, and I'll just tell you how to find the THDs also. So you have to just run this program. So when you run, once it is run, say here, the scope, you can see the stepped waveform. Okay, this is the output of this multi-level inverter. So if I double click on this scope, you will get the stepped output. So here you can see here this power GUI block. This power GUI block is generally, it is for setting like configuration parameters and all you can set in this. And mainly if you see this power GUI block, all the elements, say whenever you use sim power system block sets, you have to put this power GUI. Otherwise, you need not put. If you have used fuzzy logic, you use sim electronics, or you use Simulink, then you need not only Simulink toolbox. You need not put this power GUI. Only when you have used sim power system blocks, you have to go for this power GUI. That is because what they have done is sim power system, whichever blocks are there in sim power system, they have made the state space model. They have made all those blocks using state space model. Okay, when these state space model, they have linked with this power GUI in order to do analysis. When you want to do FFT analysis, when you want to do load flow analysis, they have linked it. So what, in some sim power system, all the blocks are linked with power GUI. If you don't connect it, then it will give you an error there. So that's why you have to put power GUI in this case here. Okay, is it understood? So why they have MATLAB, they have made the state space modulus. What are the different models available? Any idea? Say you have a thyristor. They have made the state space model and they have linked with the power GUI. So can you just tell me why do you require this state space model? What are the other models available? Transfer function model you have heard? What is transfer function model? It is the Laplace transform of output by input. So in that case, all the initial conditions are also zero. Okay. So in transfer function model, mein kya problem hai? Only the input output you can analyze. But intermediately, say there is a capacitor, how much it has charged or something, all those analysis or initial value of a capacitor is not taken into account. You have differential method, differential equation models. Okay, ODE models are there. So many models are there. But state space model ka advantage hai ki it will take all the initial conditions. There is no initial zero condition. Hum nahi denge. All the initial condition will be taken. Next thing is, it is even intermediate analysis can be done. Okay, all the states of capacitors, inductors will be taken into account. It can be used for MIMO systems, not only single input, single output. You can use for multiple input, multi-input and multi-output systems. Non-linear systems, it is not only for linear time variant, invariant system. Transfer function will be linear time invariant. These are linear time variant systems. So that's why MATLAB also what they have done, they have taken the state space model. Like, here if you see only these are block sets. But actually if you see, there is a very great thing going behind this. They have, for each and every model what you see, they have made some models behind and those models are running and giving you the result here. Okay, yeah, many algorithms are there. So now our results are, simulation is run. So I just want to cover up that time. So that's why I was just discussing about it. And anyway, you also got the knowledge about it. So now see, I'm just clicking on my scope. So I can just see the waveforms here. It is not much clear. Let me change the color and show you. So you can go to the style and change the color. So I'm just changing the color and let me put a red color so that it will be a little more bright. Apply and okay. So I think now it is still a little more clear. If you want, you can just see it like this. You can see here, this is the phase voltage. In phase voltage, you will have this 11 step, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 step. Okay, in phase, aapko itna level ho gaya. I think somebody is dialing. And in line voltage, if you see, there will be 21 steps. Okay, line voltage में आपको यहाँ जो बीच के एक है, so there will be totally, when you count from here to here, there will be 21 steps, not 22, there will be 21 steps. And the current waveform is also shown here. So now we want to find what is the THD. हमारा main aim है कि THD should be less than 5%. Okay, that's why we have gone till 11. So there, I already told you power GUI हम क्यों कर रहे हैं, because all these THD analysis can be done here. So I'm just clicking on this power GUI block. So go to FFT analysis. Okay, and just go to this input 2. That is the line voltage, because line voltage में THD find करना है. So I have just display. Okay. So you can see here 4.76%. So 4.79, that is less than 5%. But still, if you reduce still lower than this, that is better. So you can, but in neutron diopside itself, it has reduced it. You can go for other methods also. You can bring it to 2%, 3% is best. Okay. So now if you want to see, the uh, individual harmonics, what you can do is here you have option for bar. Here you can see bar relative to fundamental. There you have to change it as list. So if you give list, so you can see list up de diya, or you just click on this. So automatically you can see the list here. So here our main aim should be all the individual harmonics should be less than 3%. Okay, so वो देखना है, and all the even harmonics should be 0. If your model is not correct, आपने multi-level inverter जो model you have made, it is not correct, even harmonics will come here. Okay, I have models like that also, which even, so you have to be very careful in making the inverter. Whenever you make it, you have to see that even harmonics are cancelled. So you can see here, even harmonics, say fourth harmonics, sixth harmonics, eighth harmonics, all these are 0. And the odd harmonics, third harmonics is 0.03. 0.03 is very less. Okay, and say fifth harmonics, it is 0.05. Your seventh harmonics 0.01. Ninth harmonics is 0.09. 11th harmonics is 0.0. So till 13th harmonics we eliminated. Is it? Till 13th harmonics we eliminated. So you can go down and see. So आप देख सकते हैं कि 17 harmonics is 2.17. हमने 17th harmonics eliminate नहीं किया because selectively we choose. That's why that 2.7 is contributing to that 4 point something. Okay. So we, according to our aim, the deadliest harmonics we eliminated and we brought it down. So individual harmonics also you can analyze like this. Okay. So now our aim is to find this modulation index ke liye, for GA what should be the angles. Okay. Or PSO what can be the angles. How will we find it? So just I'll just give you some insight on GA and PSO, because without those, if I explain also, you will not understand. And then I'll just show you the program, how to write. You need not worry for that. So now, next we will go into genetic algorithm. Okay. So genetic algorithm is the most commonly used prominent computational algorithm introduced by Richenberg in 1960 and developed by John Holland in 1975. This is an evolutionary algorithm which mimics Darwin's theory of evolution. So one thing you know, in genetic algorithm mein kya hai? You are all familiar that survival of the fittest, that is also there. And every time the offspring which is formed, or we are better than our parents and our children are better than us. वो कभी भी हम तो हमारे बच्चों को, we used to scold them, you're fit for nothing, you're not doing this, that, I was like that, I was so good. But one thing you have to accept, our children are better than us. They have more brain than us. Their character will be better than us. That is so sure. Okay, so that is life. That is in the nature. When you go forward, there will be a better solution. So that is what they have used here also. When there is a new generation coming, that surely will be a better one. So how is it? That is what we are going to see here. So generally, if you see the structure of a cell in a human body, so this is a cell, okay, and the cell will have a nucleus. That nucleus you can see here, there is a nucleus, and the nucleus will have chromosomes, and these chromosomes will just cross, like say these chromosomes inside have DNA, and these chromosomes, there are 23 pairs of chromosomes, and these chromosomes, when they cross, like हमारे parents की जो chromosomes cross होते समय, new offsprings, you get the child, which is a better combination. So inside this chromosomes, they are made up of proteins. You have this different characters. The DNA में आपका different characteristics है. It may be a particular person's skin color, the eyeball color, the hair color, his characteristics, like if he's having some diseases like sugar, pressure, or all those things, everything is there inside his DNA. Okay, so now what is really happening in our body? When these cross, our parents' characteristics and the mother's characteristics we get, but God has created in such a way that mostly we will get the good and we go forward. Okay, so that we will see how our algorithm also will work. So in genetic algorithm, mainly when you do, you just first choose a population. Okay, so यहाँ population क्या है, which is the solution. Okay, population is nothing but a solution. So in our case, in multi-level inverter, what will be a solution? No, that is your function. That is your like that you can say objective function. What is the solution? Firing angle. Okay, your firing angle is your solution. That is your population, or you can say your solution. So first of all, आप firing angle को choose कर देंगे, and you say those are your best parents. Now what they do? You go on changing these. You produce new offsprings, and say for example this room. This room is there. Okay, and the best solution. Let us take the best solution is this camera, the front. That is the location where the best solution is there. And we are the population here. So what we do, these population, we move towards our best solution. So you have different things. First, we take the population, we evaluate it putting inside a fitness function. जो हमारा THG का equation है. So all these answers we put in the THG, we see whether a THG is minimum or not. Okay, so that is the first step we do. Yes, it is almost near to, like say 5 के नीचे होना चाहिए, say 6 मिल गया. So again we have not reached. So what we do? This is the parent. From these parents we produce their children, and that children again moves towards the solution. So there is some process that let us see here. First of all, the PPT, please. So first we just choose the initial population. That initial population is a solution. We just evaluate the population. How will you evaluate? You will put it inside the fitness function and see whether it is reduced or not. Then we see the criteria, termination criteria. 0 reach ho gaya or no? Or we say 10 times you do it. Is that 10 reached or not? We are seeing. No, then select the parent. Again, you just choose the best parents. Then from that parent, you reproduce and you do some process like crossover and mutation and produce your new offsprings. Again, that offspring is the solution. Just call is coming. Again, just put that in the evaluation function. Evaluate whether they are good or not. If they are not good, eliminate that population put them out of the room. Don't take them and go forward. So this is the process which we follow in GA. Okay, so we will just see the process. What are the different process? First is choosing the population. Population जो हमने firing angle बोला था. Whenever you write algorithm, it is not necessary that it should be in particular form. You can have a bit string, zeros and ones में binary form में हो सकता है. Whenever you are writing inside a computer, zeros and ones are good because computer will understand the binary language. Otherwise, you can have real numbers. You can have some permutations of elements. You can have list of rules also. You can have program elements. You can have or any data set. It can be of any data type. Population and how many population we should choose. से अभी हम 4 लोग हैं, 4 लोग ही बस है और 10 लोग चाहिए, वो कैसे choose करेंगे? So population size mainly depends on the what type of problem you have taken, one thing, and next is if you choose a small population, sometimes you will be just within a small area, you will just search and you will leave it. You will not get the best solution. If you take a very large population, the algorithm will go on running and time is wasted to go and reach there. So you have to choose an optimal population. That is also a very important thing. Next is selection. How will you select a parent? So first मैं क्या करूँगी? I'll be just choosing 2 parents, okay, and I will just put it inside my evaluation function like the THD, and I'll see whether they are good. They are going towards 0. Yes. So उसमें क्या है? When you put it in the evaluation function, you will get different answers. So we will say that which answer is very more close to your solution. So उसको choose करने के लिए, parent को choose करने के लिए, you have different method. You have a tournament. आप 2 parents के बीच में एक fight कर रहे हैं और कौन सा parent जीतेंगे? They are the best. Okay, that is tournament method. Or you have roulette wheel. एक roulette wheel में, so that method is a common method used. I'll just tell you next. Rank selection is there. Boltzmann, many methods are there. Roulette selection, MATLAB uses this roulette selection. Roulette selection में क्या है कि जो fitness value किसका बहुत अच्छा आया है probability से. For example, there are 5 members. Okay, first member का जो answer है almost close with it is 31% correct. Okay, and say second person का 5% है. The raw pink one is 38%. The blue, the green one is 12%, and the fifth one, that is the brown one, is 14%. So, what is the chance of getting selected? If you see, what is the probability? So, probability is nothing but function divided by summation of all the other functions. So, in this case, say I am giving each one of you, like I am telling you, आप लोग 100 rupees इसमें रखो और किसका मैं रोलेट व्हील को रोटेट करूंगी और किसका चांस आ रहा है. से अभी सर का आके कर्सर स्टॉप हो गया. आई विल गिव डबल मनी टू हिम. ओके, आई एम एवरीवन, आई एम गिविंग यू अ चांस. व्हिच वन विल यू चूज? थर्ड. ऑल विल चूज थर्ड. से मैं अभी सबको बोल रही हूँ एक अभी हम गेम खेलेंगे. सब आके अपने अपने कीप योर मनी हियर एंड आई विल, इफ योर चांस कम्स, double. So all of you will, which one you will keep? Third. Mostly you will go for third. Why? What is the reason? Largest area hai, and you have that probability of getting that. You don't know whether you will get that or not, but the probability of getting that is more. So here the pink parent is having a better solution. So the probability of that parent going and reaching the solution is the best. Okay, so you have different techniques. This is how you do the roulette wheel. When you take an example, you will understand it. So here, next step is, once you select the parent, next step is going some process called crossover and mutation. For example, say हमारा parents है यहाँ, you have a mother and father, okay, and they are carriers. Carriers in the sense, वो कुछ characteristics carry कर रहे हैं. Say for example, they are carrying some disease like say sugar है. Okay, they are carriers in the sense उनको sugar नहीं है. अभी जाके test किया तो भी they are normal. But उनके grandparents और उनके parents के पास था, and they are just carrying that characteristics there. They are having that. So how will their when they cross, when these two parents cross, how will their solution be? Their child will be unaffected child हो सकता है, because both the blue is without any problem. So आपका जो like एक boy हो सकता है जिनका blue मिल गया, unaffected है. You can have a girl, mother का और father का मिलके, she may be a carrier of that. और एक boy हो सकता है, he may be a carrier. Or you can get a girl or a boy who is not affected. उनके पास ये sugar ही नहीं है. She is a better solution. So that's what we are saying. When you go forward, you carry your parents' characteristics. And here you can see a family. Here US family है. A black has married a white lady. And उनके children आप देख सकते हैं. In this case, you have, their children have white child भी है. एक child है, उनके father और mother के characteristics. Like say hair, this child, if you see, hair is like a father little, mother की fairness आ गया, but characters like face cut वाला father का है. So you have a mixture. Like when you cross, automatically father and mother के बहुत सारा features उनके पास आ जाता है. Next is, say you can see here different characteristics. The first case, if you see, it is a granddaughter and grandmother. You can see how close उनकी face characteristics से पता चलते हैं कि दोनों almost same characteristics. Grandparent, यहाँ देखो, grandfather and grandson, how similar they are. They are carrying, grandson is carrying most of the characteristics of the grandfather, and here father and son. So उसमें भी देख सकते हैं कि not only the facial or all these expression, उनकी जो what to say, way of expression, not only the way of expression, उनकी talents, इनकी जो गिटार की टैलेंट है वो उनकी फादर की गिटार की टैलेंट अपने सन को भी आ गया. ओके, उनकी ट्रेड्स, दैट इज व्हाट यू कैन से, दैट विल आल्सो कम. सो दिस इज नथिंग बट योर क्रॉसओवर प्रोसेस. ओके, सो क्रॉसओवर इज नथिंग बट रिकॉम्बिनेशन. सो यहाँ मैंने बोला स्ट्रिंग और कुछ भी हो सकते हैं. सो व्हाट विल हैपेंस, ए क्रोमोसोम 1, सो क्रॉसओवर होना चाहिए तो दो लोग तो चाहिए, एक पेरेंट, एक मदर एंड एक फादर होगा. सो हियर इन दिस केस इफ यू सी दिस इज वन क्रोमोसोम and this is another chromosome, 1 point chromosome. any 1 point में आप क्रॉस करो, और ये जो क्रॉस होने के बाद ये रेड ऐसे ही है, ये जो नीचे फादर का ब्लू ऊपर चले गया. सो चाइल्ड had got this. Similarly, ये सेकंड ऑफस्प्रिंग, सेकंड चाइल्ड है, फादर का ये हो सकता है, मदर का ये क्रॉस हो सकता है. That is, this is 1 point crossover. Only एक ही प्लेस में क्रोमोसोम क्रॉस हुआ है. समटाइम्स 2 पॉइंट क्रॉसओवर हो सकता है. 2 पॉइंट क्रॉसओवर इन द सेंस आपका इस पॉइंट में भी एक क्रॉसओवर हुआ है, यहाँ भी क्रॉसओवर हो गया है. सो उस केस में ये दोनों एक्सचेंज हो गया, ये नीचे आ गए, ये ऊपर चले गए चाइल्ड में. सिमिलरली ये ऊपर चले गए, ये नीचे आ गए. ओके, और सिमिलरली ये ऊपर चले गए. सॉरी, ये चेंज नहीं हुआ, ये ऐसे ही है, कैसे भी हो सकते हैं. ओके, दिस क्रॉसओवर कैन ऑकर एनीवे. आपका चाइल्ड कैसे भी क्रॉसओवर के हो सकते हैं. सो मेनी साइंटिस्ट हैव कम विथ मेनी टेक्निक्स. नेक्स्ट से अर्थमेटिक क्रॉसओवर. सो 2 पेरेंट्स हैं, अपना चाइल्ड एंड ऑपरेशन हो सकता है. से 1 into 1 1, 1 into 0 0, 0 into 0 0, 1 into 1 1, 1 into 1 1, 0 into 1 0. सो ऐसे कॉम्बिनेशंस भी हो सकते हैं. ओके, सो हियर दिस केस क्रॉसओवर में क्या हो रहा है, यू आर जस्ट crossing 2 parents and you're getting the characteristics and it is moving, and in that case every time our child will be better than our parents, हम बोल रहे हैं. Next is mutation. Mutation क्या है, extraordinary child. Okay, so Einstein, उनके पेरेंट्स इतना ब्रिलियंट नहीं था, वो कैसे हो गया, उनके पेरेंट्स में कुछ एक फीचर होगा हिडन, और जब वे म्यूटेट हो जाते हैं, से पूरा मैं दिखाती हूँ क्रोमोसोम्स में कैसे है, एनी वन प्लेस में सडनली चेंज हो रहा है. Okay, so that is, for example, in GA में देखते समय, I can just give you an example. Say आपका बहुत सारा minimization, you are just finding the minimal output. Okay, so you have a system like this which has many minimum. Okay, so इस case में this is also a minimum, this is also a minimum, this is also a minimum, but actual minimum कौन सा ये वाला है? This is said to be the global minimum. So when you run the program, what will happen is, say आपने यहाँ से शुरू किया, वो जाके इसमें आ जाएगा. Okay, मैं minimum find कर दिया. It will get locked there. So this is crossover. Crossover will go near the answer. Sometimes it will get locked in the local minima. So what in mutation it does? Suddenly it will go and change at some other location. यहाँ change कर दिया, यहाँ आके minimum, फिर suddenly यहाँ change कर दिया. So there is a chance, when there is, you do mutation, there is a chance of getting the global minima. Crossover में जाके stop कर दिया तो sometimes there is a chance for getting locked in the local minima. Okay, so mostly that's why we say we have to go for mutation. But there is a risk in mutation. Mutation is of 2 types. One is positive mutation, one is negative mutation. So ये जो Einstein का बात हमने बोला है, that is a positive mutation. Okay, so this is a positive mutation. अच्छा, उसका brain इतना बड़ा है, he came with inventions. Okay, it's a positive. But you can have negative mutations also. Osama bin Laden भी हो सकते हैं, और से here. So Osama bin Laden भी हम mutation नहीं बता सकते. Maybe lifetime में उन्होंने जो learn किया है, उसमें उनका change हुआ होगा. He is also a very brilliant guy. He is an engineer, बहुत बड़ा. He is a rank holder first. ऐसे बोल रहे हैं. So he also maybe a positive mutation ही है वो भी. But उनका brain wrongly चल गया, वो कभी भी हो सकते हैं. उनकी parents बचपन में तो ठीक हुआ होगा. Is it? So that is not a negative mutation, according to me. Might be आपके हो सकता है. That is also a positive cross and a very brilliant fellow. He is also a brilliant fellow. Okay. Due to might be process of learning process में उन्होंने wrong learn कर दिया. So I will not never say that is a mutation. This is mutation. यहाँ देख लो. Positive. या से पा का ही एक यहाँ दिख रहा है ना. So childs are like that. So he's say a child with 10 fingers in one leg में 10 fingers. So these are mutation. Negative. Physically handicapped है. So that is all. These are negative mutations which are unexpected. So there are positive mutations and negative mutations also. Okay. So what is mutation? Say आपका एक chromosomes ऐसे हैं और suddenly एक chromosome को आपने change कर दिया. Okay. पूरा lot से आपने एक को जाके change किया. So this is a पूरा lot, उसमें जाके आपने एक value को change किया. So that is said to be a mutation. Mutation का अच्छा mutation भी हो सकता है. If you do a mutation, you can come to the exact solution. Sometimes you can go out of the solution also. You will go into a wrong solution. So many places में लोग mutation करता नहीं है. वो सोचते हैं कि अच्छा छोड़ो. कुछ लोग brilliantly करते हैं. First they do crossover. Crossover करने से आप solution के बहुत पास में चले जाएंगे. That is said to be exploration. And then exploit it. Then you will do mutation. Okay, so crossover करके जब से यहाँ के solution वहाँ वो जो कैमरा तक चलेगी, that is our solution there, हमने ऐसे डिस्कस किया. वहां जाके म्यूटेशन कर दो, वो करेक्टली जाके आपको एग्जैक्ट सोल्यूशन, एग्जैक्ट पोजीशन लोकेट करेंगे. कुछ लोगों ने अपने कुछ पेपर्स देख लिए तो दे हैव डन म्यूटेशन फर्स्ट, देन दे हैव डन क्रॉसओवर. So that is लोगों का ब्रेन के अकॉर्डिंगली है. दे से कि मैं ऐसे ऐसे म्यूटेट करके मत करके मैं सोल्यूशन में रीच करूँ. दैट इज इन योर हैंड्स, हाउएवर यू वांट टू डू इट. ओके, सो दिस इज अ म्यूटेशन एग्जांपल. जो ग्रीन वाला है हमने चेंज किया है. म्यूटेशन मोस्टली 10% म्यूटेशन हम करेंगे. से देयर आर 20 एलिमेंट्स. So इस केस में 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 है. So 16 plus 16 there are 32. So 32 में उसका 10% like 32 in the sense 3.2 और 3 और 4 आप कर सकते हैं. So इस केस में देखो 3 places में आपने किया है 1 2 3. मोस्टली म्यूटेशन बहुत ज्यादा भी नहीं करना. म्यूटेशन करना है ओनली 10% की ज्यादा नहीं करना है. 3.2 आया था, so that's why 3 किया है. Okay, so always remember that. So this is, so as I already told you, say there are many maxima. ये maxima का problem है. So when you do mutation, you can exploit the location. Say वहां जाके lock हो गया. Okay, mutation, that is mutation. और crossover is helpful for exploring. Okay, mutation is exploiting. So दो terms है. This is crossover. Then evaluation. आपकी solution, आपने से parents find out कर दिया, आपका offspring आ गया, जाके आपके THD equation में डालो और उसको evaluate करना है. So evaluate करते समय भी what you have to do, जैसे जो change कर रहे हैं, जो answer अच्छे के पास जा रहे हैं उसको लेना है, जो अच्छा नहीं है उसको discard करना है. Okay, the solution which is going towards the like solution, like the population which is going towards the solution accepted. For example, this is Darwin's theory of evolution. Evolution में क्या है? Say birds. In olden days, they had a big beak and they had big wings. So because उस time पे they had more food, they have to eat more food, they had big beaks. Nowadays, then scarcity of food came. They have to then evolve according to the situation. Their beaks also became small, and at last nowadays you can see the sparrows with small beaks. Okay, so this is evolution. By years and years they learn it. In case if they are not learning, such persons you have to send out of the group. Such parents you have to send, otherwise your solution will be locked in minima. Yeah, they will get extincted. So that also I'll just show you. Next, I think you have heard of the story of this eagle. Okay, eagle can live 70 years, but initially uska life only 30 years hai. Each eagle only lives for 30 years. Once it becomes 30 years, what happens? Its beak will bend and its feathers will become big. Then it will not be able to eat food. It will become weak and weak. Its feather is big. It will not be able to fly. So 30 years में वो death के place में आ जाएगा. उस time what the eagle does? It goes to a very big mountain. It sits there and it has to go into a very tough situation where it will go and try to break its beak. जब वो जाके वो like बहुत difficult में उसका beak को जब break कर देंगे, once the beak goes off and it sheds off all its feather, then again new beak will come after some 5-6 months. So it will wait. That time it will not be able to eat food. So if it lives, again it has a life of again 70 years. Otherwise, the eagle is gone. Okay, so that is the thing. Well, if you're fit and you're trying to come out, then you can live the life. So here also evolution. Eagle also goes through this process. So now deletion. Which are the things you deleted? आपको जो fitness function proper आ नहीं रहा है, you have to delete it. So you have seen the dinosaur. Extinction of the dinosaur. Dinosaur couldn't live. It died. Nowadays you don't have any dinosaur. Okay. So that is evolution. When you go on, the best solution will live. All the others will die off. This is the process of GA. So now termination. So हमारे problem में क्या है? Fitness function satisfy हो गया, then that is THD is 0, you terminate the program. Or if your value like maximum iteration has reached, you will terminate it. So for example, I have just taken a simple example because जो मैंने program दिया, it's a very tough. It will run for hours. So let us take a simple problem and see first. So here we have a function x squared. This function ko we have to maximize it. We have to get the maximum solution, and they have given a range that the x value can be between 0 and 31. Okay, so first as we are going to do like MATLAB में कर like computer में करना है तो binary form is the best. So we have kept 0 as 0 0 0 0 and our 31 was the maximum. So let me keep it as 1 1 1 1 1 as. Okay, code that. And now we have to choose the population. How many how will you choose the population? So mostly you know population will be even. Okay, so एक father है तो एक mother है तो ये cross हो सकता है. So always you just imagine population when you choose, you don't choose 3 or 5 and all, you choose only 4 6 ऐसे choose करेंगे so that crossover mutation करने में आपको easy होगा. And next is the selection. So selection criteria हमने already देख लिया roulette wheel का, so roulette wheel से हम select करेंगे. Okay, so this is clear. So first let us take a thing. I am randomly choosing some 4 population. Okay, so randomly I am just choosing 4 parents. So my parents, X value is, say this value, 1100 is my 12, 11001 is my 25, 101 is 5, and this is 19. Okay, so now what I'll do, I'll put these value inside my X squared fitness function mein. So 12 squared is 144, 25 squared is 625, 5 squared is 25. So fitness value मैंने evaluate कर लिया. So इससे ही मुझे like from this itself I can understand my this fitness value is the maximum. Okay, so this 25 solution is good. I understood it. This is a simple problem you understood. When you take a big problem, you will not understand. Okay, so let us just see this. I am just finding the sum of all these terms. That is 1155. The average is 288.75 and the maximum value in this is 625. Next, I am just finding the probability. In the sense, I told you the roulette wheel selection ke liye probability ki which will be selected more. So in that, what I have to do, probability is f of x is 144 divided by summation of all the value. That is 144 divided by 1155. Okay, you can see here the formula. Once again, I'll just maximize this and show you. That is f of x divided by summation of all these things. Okay. Okay, so when I do this, automatically you can see here 144 divided by 1155 is this value, 625 divided by 1155 is this value. So iska percentage mujhe chahiye because roulette wheel I showed you different percentage. So this was my percentage 12.4, 54.11, 2 point this. So if you just choose a roulette wheel, so you have a 54 in the sense a 50% hai. So 54 is somewhat like this. Okay, so this is 54% and 2% is very less. And then you have a 32 and this 12. So this is 31 recurring a 50. So you know that the roulette wheel rotate kar diya, the probability of choosing this 54 is more. Okay, so yahan to humko easily understand kar liya, but when you do in MATLAB or some other, the system should understand. So what we do is expected count. The next thing, expected count is nothing but your function f of x divided by this average value. 144 divided by 288.75. That is same thing like this probability only. So you get it as 0.4, 2.1, 0.0, 1.2. So now just round it off. 0.4 hai to less than 0.5 hai. So it's almost 0.5. That is 4.9 enough for 0.5. So let me keep it as 1. This is 2, 0 and 1. So now it is easy for me. When it is 0, I can eliminate this. This parent is not good. इसको eliminate कर सकते हैं. 0 हो गया. Okay, that is the selection में ये counts किसको select कर सकते हैं जब इसको eliminate कर दिए ये 2 is best parent. So I can just repeat this. Next parent के लिए मैं क्या करूँगी इस parent को यहाँ का इसी same number को यहाँ repeat कर सकती हूँ because that is having a better solution. Okay. Okay, so now what I'm going to do is I will just delete this one and repeat this one here. That is what I am going to do in the next case. So I can see here now the mating pool. Okay, this is your you can see here this 5110 101 को eliminate करके हमने 11001 ही डाल दिया यहाँ. Can you see this? The same thing I have repeated here also. That yeah, 2 and 3 are the same. I told you why I deleted 101. That is 5 was not good. So now next one, what we have to do? We have to do crossover. So you can do your own crossover. 3-point crossover, 2-point crossover और AND logic or कुछ भी use करके यहाँ first parent के लिए मैंने like fourth location में crossover कर दिया और third and fourth parent के लिए मैंने third location में crossover किया है. So what I have done, क्रॉसओवर में इसको यहाँ ऊपर लेके चले गए और इसको नीचे लेके आ गया. Similarly, these two values I brought it down and this one I took. So that is what I've done here. So now my new X value is 1101 is 13, 24, 27 and 17. Again I'm finding the fitness value. Again do the same process what we did last. Okay, so abhi mera fitness value ye hai और my new X values are these are my new X value and this is my new parent. Now after crossover what you have to do? You have to do mutation. So mutation कितना करेंगे? यहाँ 20 variables है. 1, 2, 3, 4, 5. So 20 variables है. So 2. That 20 में 10% is 2. Only 2 करना है अभी. So next mutation. So mutation में मैं अभी क्या करने वाली हूँ? Only 2 कर रही हूँ. So ये first parent में ये करूँगी मैं. Okay, and second 2 parents में ये कर रही हूँ. Oh, that is your choice. Wherever you want to do mutation, you can do it. That is your mutation is good. You will get a good answer. If your mutation is wrong, आपका जो 10 finger वाला है ऐसे मिलेगा. So you have to be that also it's a lucky mutation बोल सकते हैं. Okay, so here say I've changed this 1. So इस location में मैं 1 कर देती हूँ और यहाँ जो 0 है इसको भी मैं 1 कर रही हूँ. So that is my new mutated offspring. So यहाँ this is nothing but my 29, 24, 27 and 20. So you can see this when the process goes on, the young less values got eliminated and we are going towards the solution. So आपका solution देखो तो maximize कर रहे हैं ना, so maximum value के towards हम जा रहे हैं. Okay, is it clear? So this is the process which is really going inside. Okay. So this is the algorithm. Okay. So MATLAB में करते समय we have to just tell MATLAB what type of crossover we are doing, what type of selection we are doing, what type of mutation we are going to do, or what is the population size. So you can see here हमने initially 40 population size रखा है. Mostly papers बारे में देखें तो 30 तक लोग 30-40 use करते हैं. And generation मैंने 100, that is iteration 100 times iterate कर रहे हैं. और population range 0 and 1 रखा था. Crossover, selection, everything जो MATLAB में है उसे यहाँ crossover, scattered crossover use किया. So different parameters you can define. And your evaluation function. So f of I, this is nothing but your THD. Okay, so that is here absolute value ले लिया. Otherwise it is nothing but square root of your all the F2. F2 क्या है? Fifth harmonics है. That should be 0. Okay, so यहाँ like 0 squared आ गया तो best था. So that आपका THD भी 0 होगा. But fifth harmonic slightly होगा कम value. So that value उसका absolute लेना है 7th, 11th, 13th divided by fundamental. So this is your fitness function. Okay, and this is your F1, F2 value. वो भी define कर दिया. So आप इस fitness function को go on evaluating for minimization. And आपका ये क्या है? This is your constraint. आपका angle कैसे होना चाहिए? And you will be choosing the parent. Then you from the parents you will be selecting the crossover and mutation you will be doing. Then again you will be seeing the termination criteria. You will be evaluating them and going towards the solution. Okay, so this is MATLAB. Next PSO भी मैं बता देती हूँ. Then I'll just show you the MATLAB because PSO में भी same ही है. PSO में next क्या करना है? उस केस में भी उसका parameters initialize करना है. Same fitness function. Problem तो same ही है. Same constraint and you will be doing the same process. But there instead of crossover and mutation you will have something else. So that we will see what is. We are going out of time also. 4 बजे होने वाला है. So I'll just finish it fast. So PSO में क्या है? Say every time a group of birds if you take a group of birds, they always fly towards the food. Say you have a food and all the birds will fly towards the food. Always they take the shortest distance. Is it? They always birds want to take the shortest distance and go towards the thing. So एक bird भी से उसने find out कर दिया कि shortest distance है. All the birds will turn towards that and it will move towards the solution. Same way say एक fish tank है. You are just putting some food into it. You will see that all the fish will come towards the food and that will take the shortest path and come. So this is a group of birds or a flock. A group will move in a group and they will always take the shortest path towards the destination. So here also I'm not going in depth, like since we are short of time, I'll just tell you, say हमारा इस case में भी हमारा population we have to take and population is nothing but a solution. In our case it is the angles. Okay, so here you can see this is your solution. Okay, X is your solution, and it is moving in one particular direction. It is, and with a particular velocity. The bird is moving in one particular direction and with one particular velocity. So what the bird will do, वो कैसे उसको पता चल रहा है कि the food is at that position? It will first look at the food by itself. Okay, it will take its own decision. It will see its neighbors. Is surrounding की neighbor देखेंगे. Is the neighbor moving to what position? And it will see the global, whole the bird. With all these things, it will decide what should be my velocity and what should be my direction. So here you can see the bird was flying in this direction. So this is the vector sum. So this was bird, like I'll just show it in red. So this was the vector sum. So bird was flying in this direction. After that, is uska personal best yahan tha. This was its personal best. According to the bird, this is the best position. So it will take this direction. Okay. After that, it is seeing its neighbor. According to the neighbor, the best position is this. So it will just take this direction. Now its new position is this. Its new bird's new position is this. So it has changed its direction. This is the new direction. Okay. And its velocity, new velocity will be Vt plus 1 will be its new velocity. Okay. So now we have to find what is the new velocity and what is the new position. That is PSO. PSO में दो equation है, दोनों को solve करना है. So bird will every time change its own position. It changes position with its own decision as well as its neighbor's position. So here you have some parameters. You can see that here this is the velocity का equation है. It has something called the inertial weight. It has something the cognitive weight. Cognitive weight is nothing but its own, based on its own position. And C2 is nothing but its neighbor, social parameter we say. Okay, so we have to just fix the weight, social parameter you have to fix. You have to fix the cognitive parameter plus the inertia weight. So inertial weight, if you see, that will again the crossover and mutation ke jaise hai. If the inertial weight is very large, it is almost going towards the solution. Okay, and after that, if it is very small, it will start exploiting. Okay, first is exploration. If the large, it will explore. If it is small, it will exploit. So what you have to do is initially it should explore. So initially the value should be large, and as it goes towards the solution, it should exploit. So the value of C0 you have to decrease it. You have formulas for that. You can do it. Okay. So similar to there, mutation is exploitation and crossover is exploration. Same way here also C0 value will vary. C1 is according its best position. So you can see here its position is P in and X in is its best position. Its best position as well as the like uska personal best hai or uska personal direction hai. And this is G is in the sense global, the sense neighbors. So that's why C2 is coming with the neighbors value. PGN minus its ka like us time ka particular position. That is this X position is nothing but X in. So isme personal best, the global best. Okay, GN is the global best and P in is the personal best. So accordingly, similarly, how the direction will change? The new direction is nothing but the old direction plus the new velocity. So new velocity which with it is moving and what is its new position accordingly is you will choose. So ये algorithm भी ऐसे ही है. So I think we are going out of time also. Which one? Dimensionally, if you see velocity should like, because every time direction you, but the thing is it is moving in one particular direction, but how much distance here it is the distance. Now X is nothing but the distance traveled. So distance traveled depends on the new distance as well as the velocity which it is moving. The velocity is less, automatically the distance traveled also will be less. Okay, so the distance will depend on the velocity also. Say if आपका velocity slow कर दिया, automatically you will travel only less distance. Okay, so the distance will depend on the velocity also. But आपने जो physics equation use करके यहाँ think नहीं करना. These are algorithms. Algorithms are different from those calculus equations. Okay, जो हमने यहाँ equal लिखा है, you need not see the units or all those things here. These are algorithms. So in this case also, what are the things you have to define? You have to see the different parameters like the social parameters, cognitive parameters, and the position, all these things, generation, population, all these things initialize करना है. Then लास्ट केस में आपने ये मैं भूल गई आपको बताने के लिए. इस केस में क्या है कि अकॉर्डिंग टू रूबन, वन ऑफ द पेपर ऑफ पीएसओ इज देयर. अकॉर्डिंग टू रूबन, you can just search for Ruben's paper of PSO, you'll get, he has given a general thing ki aapka C1 plus C2, that is social parameter and cognitive parameter value, should be greater than 0 and less than 4. Similarly, aapka jo inertial weight hai, that should be greater than C1 plus C2 divided by 2, and it should be less than 1. Okay, so this is some like standard given. So most of the papers, latest papers, if you see, they go according to his solution. So you have to see those conditions, whether those conditions are satisfied. Then we are updating the velocity. Then we evaluate them with the constraints, and we will see ki whether abhi humne solution reach kiya hai nahi. Otherwise solution reach nahi kiya, again the new best position. So old position ko next best position se replace kar do and go on doing the process in order to achieve the best solution. Okay, so this is how you do it. So now we did with different, I'll show you the algorithm at the end, ab kaise run karna hai. So here we did with Newton-Raphson, GA and PSO, and these were the angles we got for different modulation index, and usko THD humne find out kiya. So we found that, say here this green one was for 11 level GA, that is so thick line. So this one, so here you can see 0.65 modulation index ke liye और 0.9 के लिए भी minimum THD मिला है. But 0.65 हमने modulation index ले लिया तो क्या, what will happen? Your output voltage will be less. So 0.9, in the sense it is almost towards 1. Say 240 was your aim. So you got 230, that is good. If you get only 130, you will not take. So 0.65 is a modulation index, 0.9 was good. So for 0.9, we will be finding all the THD, and we will try to keep the system at that 0.9 modulation index. So here all the THDs was found. And for the particular, for the Newton-Raphson method, the 0.8 gave the Newton-Raphson with 11 level, this red. So red was, I think here again, 0.8 maybe. Newton-Raphson method is dotted, is it? So dotted में देखना है, dotted में blue है. So this is the dotted blue. Okay, this is GA. So उसमें 0.8 के आसपास है. So यहाँ minimum है, dotted. You can see here. So बाकी place में ज़्यादा है, and it is almost coming minimum at this point. Okay, so like that was examined value के accordingly. So 0.8 was taken here, and the THD was, like, say the graphs was drawn. So मैंने दिखा दिया already, graphs I showed you MI के लिए. So same thing. So THD also how to find, I have just shown you. So here you can see when we did the simulation, voltage के लिए 5.55 was the line voltage. This was for current 5, and phase voltage was, see here, phase voltage, spectrum voltage was 7.93%. Okay, so now the individual harmonics, that also I showed you. List डाल दिया तो individual harmonic आएगा. So that also we have just made it, put it in the table for voltage, current, and line voltage. Then yeah, this is my result. Yeah, what I did it for my PhD. Okay, so all these things what I showed you is my PhD work, so I can confidently tell you about, like, what we did. It is the actual thing. It is not anything taken from some other paper or anything. Confidently, these are the results what we got. Then after that, it was hardware implemented. Okay, so block diagram is shown here. You have the multi-level inverter here. We just tested with an induction motor. So power quality analyzer was connected in order to find the THD in hardware. There I showed you power GUI. We did it in simulation. Now simulation result and hardware I have to test. Na? So power quality analyzer, that is fluke meter, was used here, 435, and that was used for finding the THD. And here, as I already told you, current sensors, and for protection purpose, again it was used, driver ICs, then signal conditioning circuits. So this, I think Sandeep would have given you insight on all the circuits. So the same thing, and FPGA. You can use Arduino also, because 50 Hz only, not a problem. We went for FPGA with JTAG से हमने MATLAB के साथ we just connected it and we found the result. So this was the hardware setup in the laboratory. So 11 level 3-phase cascaded H bridge was done. So here you can see here, this was the 11 level cascaded H bridge inverter. So this is with FPGA. This I'll be showing you for the participants here. We can go to the lab and see. So here, this is the 11 level inverter, like FPGA. I have given the firing angles here. So जो भी modulation index है, 5 angles I have to give. I have given here. Through this wire, it is going to the multi-level inverter. So here I've used a DC, like DC voltage. Instead of PV, I have just given rectified and given, or I can use 15 PV and I can give it. मेरे बेटे का है. It's my son. When I was doing recording, like he was also there. Because when I was doing, I used to do Sunday, Saturday, night, sitting and doing. Then only we can fully finish it. So this was recorded at that time. I can mute it also, but.
He is your source of inspiration.
So this you can see here, this is the 4 H bridges there, and with this is the driver circuit and opto coupling. Okay, and this down here, these are the isolation circuit, because I said to you power electronic circuit should be fully isolated. We had rectifier circuit and fully isolated, and these are the signal conditioning circuits. Okay, these are the 3 current sensors. Like load ke side mein current sensors use karke we were just measuring. So these are also the signal conditioning circuits there. This is for signal conditioning purpose, and gates, that is for protection purpose also. These are the clamp meters, like power quality analyzer ka jo current probes and voltage probes, and this is the AC, like load current you can see here. Okay, and you can see here the power quality analyzer. So this is the power quality analyzer connected with the laptop. Okay, so power quality, this is the laptop mein software mein we can just see all these things, and you can see the output voltage also, what the steps what you can get here, the voltage 129, all these things, and we can just measure the THD also. So you can just see how to go and see that harmonics. Just go to this is the voltage, you can just see all the voltages. Okay, then you can go to harmonics. If you go to the harmonics, आपका उसमें harmonics THD आ जाएगा 3.2, you can see here. Okay, so here this is the voltage harmonics, A phase. Then you can go to the B phase, C phase, like B and C phase. Then current. So current harmonics also THD you can see around 6 point something it's coming, and you can just see all these parameters. So it was an induction motor was used here. So we did the experimentation both with star connection and delta connection, and we just saw all the results. Okay, so here the DC was the input, so you can see the DC voltages here. Okay, so around 15 DC voltages. The induction motor was used as a load. You can even connect it to the grid or anything. See, AC was the output. So AC, the induction motor was connected. DC, I have to connect here PV panels. I required 50 PV panels. I had only one PV panel where multi-level inverter I've done. So what I did is I rectified and took individual isolated 15 DC supply, and I gave as input. Okay, so with CR 12 volts. 12 volts, because this induction motor also rating was only like 120, like 440 volts. The induction motor was 440, but the output voltage I got was around 120. That is ground to peak was, that is 240 was the voltage. Okay, so accordingly this was the overall system. After that, this was the fluke meter output what I got, and the THD also we measured all the THD values, and the analysis like Newton Raphson, GA and PSO. So for me, if you see, like PSO gave around 3, GA gave me in hardware 2.7. So that was the best. But when I saw PSO was giving me time cut, like time for running was PSO was giving me the limited time, like what to say, simulation time. Okay, so simulation time was less for PSO and G8 was big. So when you want to go for online simulation, I gave a suggestion that you can go for PSO because PSO was giving you a better solution. Sorry, better solution as well as time was come. GA was giving me a best solution. See here, 3 and this was 2.7. But offline simulation, if you make a what to say lookup table or some artificial intelligence train karke, if you use a lookup table, then GA was best. So I was giving a suggestion that when you want to go for grid simulations and all, you can go for PSO because simulation time was faster in that. If you want to go for online simulation, okay. So if you want to see the program, I can just show you that. So we have gone out of time.
What is SHE?
Selective harmonic elimination, SHE. So PSO, I can frankly tell you, I took the toolbox from MATLAB File Exchange. I have already told about MATLAB File Exchange. It's a very good thing where GA ka toolbox, PSO also hundreds of toolboxes are there. Different people have written because you know the logic. Logic is same. So for any algorithm, that is same. Only thing you will change is your fitness function. You will write and go fit it at the correct location. That is the beauty of doing your work. You have to write your own fitness function and go fit it in the position. Okay. So here, let me just give. First of all, whenever we run, we have to go and take our PSO program and run the PSO toolbox. So I'm just, I can just show you. This is the PSO. Once again, I think once again I'll open it because so people wouldn't have seen. So I've managed first PSO toolbox, which I took it from MATLAB File Exchange. I've taken. So I have a PSO.m file. This is a common file for everyone. Anyone can use this toolbox. You can just go to MATLAB File Exchange and take it. So just double click on this program. The program will open. Just run the program. So now all the initialization will be done. I have not done anything in this. This is a general program and it is running the program. So this is okay. Now it is done. Now I'll be opening my program. Okay, so my program I have to open. So in the same folder. So multi-level inverter. So I'm just going to Shimi in this. इसमें क्या है कि it is not only one program. There are number of say fitness function, constraint equations. So I have to open everything. Then only the main program will run. So I'm just opening all the programs. My main program. Then I have to open my fitness program. I'll just show you the program also, don't worry. I'm just opening all the supporting files required for this. I have my MDL also, so that will open by itself. So then THD computation, frequency spectrum, because I just want to see my frequency spectrum in simulating environment. So that also, all these programs I have just opened. So now I'll just show you the main program. Okay, so here you can see I just kept all my DC in this constant. In this case, if you want, you can 5 level is there constant. And here, first thing is my GA and PSO say almost same program I've used for GA and PSO. And I have not changed anything. 1 second. So you can see here. So you can see the thing here. Okay, so this is for GA. इसको highlight कर दे, इसको command करके मैं PSO ले लिया तो PSO run होगा मेरे लिए. दोनों मैंने एक ही program है मेरा. So here GA is a function. What will GA do? When this function opens, it will give me my Z value and the fitness value. Okay, so GA function requires the fitness function. Okay, directly I can write the fitness function here. Fitness function also I have written many fitness functions. Okay, so that's why I've called string to function here. And then how many levels? Say 3 level at 3, 5 level I have used. This is the constraint. I have written an equation now, alpha 1 should be greater than 0, less than alpha 2. So that in the matrix form you have to give. That one I have written. So PSO के लिए भी same ही है. Only thing is fitness function at the rate fitness यहाँ directly दे दिया. यहाँ भी you can give like this. String to function को आप at the rate fitness भी दे सकते हैं. Same thing you can give it here also. Only change in this is आप last में ये यहाँ देखो G and PSO same ही है. दोनों का options में change करूंगी. Options क्या है? In this case, I'll give crossover mutation and all those things I'll define. In the ऊपर का case में I will just give my like क्या है social parameters, cognitive parameters. So option is changing here. So I'll just show you the options what I've given. So you can go and search in MATLAB file exchange. Many programs are available. Then you'll understand why kaise options लिखना है everything. Okay. So here you can see the options which I have written. First, I'll just tell you for GA. So you can see here for GA opt. 1 second. So here you can see the option. Option is equal to GA. So generation I have defined 40. Okay. Then population, if you want population also you give. If you have not given, MATLAB will take its default. Okay. So creation function. Then you have the initialization. Then I'll just move and tell you mutation, crossover. Okay. And population size, all these things you have to give. In case of PSO, you just see. There also generation, population size, social attraction, cognitive attraction, okay, constant boundaries, population initialize, all these things. If you're not giving, aapne square brackets डाल के छोड़ दिया, it will take its default. It is not necessary you have to give, it will take its default function. Okay, so this is a main program. In this main program, आपने यहाँ you saw this. I was just calling the fitness function. Is it at the rate fitness? I was just calling the fitness function here. You can see the fitness function. This is the fitness function. So I have to write the fitness function program. Similarly, यहाँ power scope मैंने like that is FFT is equal to power scope. That is my Simulink I am calling. So that Simulink के लिए spectrum equation also I have to write. So those are the things. Say fitness equation is this. So you can see here, there are two inputs coming, X and M. So that is this N R, that is actually it means N argument in. N ARG in is the command as N argument. That is, it should be less than or equal to 2. Because 2 arguments are coming, then it will do this function. Modulation index it will take. And I am just giving F1 value is the value which I want. Okay, this is the fundamental value which I have to eliminate the 5th, 7th line. So I can just go for other things also. वो आपने algorithm के accordingly है. So then computing the THG determine करने के लिए वो algorithm है. Spectrum frequency spectrum के लिए जो algorithm है. So now I have to run my main program. So this is my main program. I am just running. So I add to path because it is out of path. So first I have to run my PSO program, then I have to run this program. So now you can see here, fitness value evaluate एक time पे करके it is trying to go and think. So this is around 25 iteration. That's why I did it last because it will go on running. ये program बहुत लंबा है, so at least it will take about time. So I just wanted to show you how it runs. So now I'm getting, now if I go to the workspace, I'll get all my angles. Those angles I will just go and put it inside. यहाँ तो मैंने उसके साथ link कर दिया. If you have not linked with Simulink, you can take those angles and go and put it in the gain where I showed you. Here and what I've done is from the workspace, it will automatically call my program, put it there and give me the THD also. So here I can just go and select my THD for the second line voltage and just display. So each and every time it will display. Each iteration it will display the answer and those answers also will be saved there. So now I can see for which modulation index I am getting the minimum value. Okay. So then I don't know how much you understood because it's not so simple also. It is a 3-4 years work. So I have explained in 2-3 lectures, last work and this. But still I think you would have got some idea in power electronics and renewable source of energy, kahan jaake kya आप कर सकते हैं. Now you would have got with hardware or with genetic algorithm or PSO what you can do. Okay. Frequency spectrum is this one. I just want the frequency spectrum में आपको third harmonics, all the harmonic values will come. Okay, because that in all the values and everything will come in these, so that what I can do is even this values will get eliminated now itself. So I have to go to the workspace and get all my value if I want to replot it. So that's why that was done. But otherwise, that is not necessary. If you don't complicate your program, simple program is your main program will be there where you will be calling the fitness function. You will be calling the constraint. If you want, MATLAB में एक simple program भी मैं दिखा सकती हूँ ये छोड़ने से बहुत simple से दो fitness function and constraint से कैसे run करना है. That program also I have. Mostly when we do soft computing course, we take MATLAB का simple program से हम जाते हैं. Okay, so for that I have done, those things are also available. If you are interested, I can just show you that. उस case में only GA, only PSO, and different optimization algorithms, neural network, fuzzy logic, those things with MATLAB we solve. last month में भी एक course था artificial intelligence and optimization. So I did all these things there. उसका ही बहुत PPTs में in the sense उसका GA PSO जो किया है. It is there on my website. If you go to my Google Hangout, not Google Hangout, my slide share, you will get it.